RavenDB is a database that not only comes with a seatbelt, but with GPS and airbags to boot. We know how much work your operations team have, so we made great effort to ease things. We wanted to get started without having to pore over documentation, so we produced a setup wizard to get you up and ready in minutes. You want to deploy an encrypted database? That's just a few clicks. We want you on the path to success, so RavenDB guides you to the right decisions. You receive alerts on things like slow I/O, no backups initiated, a certain query isn't working right, and more. We don't want to be a black box. We want to show you what's wrong in the clearest and most efficient manner so you can fix it effectively. Whenever there's an issue, you don't have to conduct a murder investigation to find out the culprit, especially when an issue is approaching critical levels. We monitor every little detail so you can get into your system knowing exactly what you need to fix and where to go and fix it. You have the ability to package the debug state of your system and send it off to observe it in isolation. Today, CEO and Chief Developer Oren Aney will walk you through all of these features. You will see how they work and how they play together. Feel free to ask questions by clicking the Q&A button at the bottom of your screen, and Oren will be happy to answer them throughout the session. Enjoy your presentation, and here's Oren.
Hi everyone, thank you for joining me. This is an interesting webinar because usually when I talk about RavenDB, I talk about RavenDB in the context of developers. Here is a feature. Here is how you can do X or Y or Z. It turns out that quite a lot of our time is spent when I'm talking about our time, I'm talking about the developer team of RavenDB, not with developing new features for RavenDB, but in one of three ways. One of them is we call them paying taxes, making sure that the feature not only work, but integrate into the system, has the appropriate login, alerts, monitoring, endpoint, those sorts of things. The other thing that is very important is that we try to make the feature smarter so you don't have to really think about that. And that's important. In many cases, the level of complexity that you have to deal with in some of those things is quite high. RavenDB is a distributed database. It has automatically failover, automatic encryption, a whole bunch of other things that if you need to dig deep into them, they're deep. But for the most part, we don't really want you to think about that. This is supposed to be our responsibility, and you should be just a user. That's it. The third thing that we have to consider is how to file away any sharp edges in the system. So let's start. So now that we know what is our aim, let's talk about operations in RavenDB. And the first thing that we need to understand is what does it mean, operations? Operations from our perspective means that we want to keep the system running. Regardless of what's going on, the system should keep running. And that's interesting. What does it mean to keep the system running? It means that to the largest extent possible, regardless of what's going on, your application should still work, which means that we take upon ourselves quite a lot of responsibility. If thing goes wrong, we need to still be able to function. And RavenDB does that. RavenDB does that by doing things such as automatic failover. It does that by integrating the topology to both servers and clients, so each one of them can act independently. But let's look a little bit deeper. The number one requirement that we have for RavenDB is that you should be able to handle itself. Basically, you don't want to have a babysitter for a database. You want the database to run on its own. And that's my definition of what is to have a grown-up database. Now, let's talk about what it means. It means that, for example, just two very small examples. In many databases, you have a lot of configuration options that you can choose. For example, size of the buffer pool, amount of query cache, a bunch of other stuff. A lot of them are increasingly related to one another. Now, some databases have literally hundreds of such parameters. And it gets to the point that it's absolutely ridiculous. If we take RocksDB for Microsoft, for example, it has something in the order of between 50 to 100 different configuration parameters, all of which may have impact on one another. And if you go and read the documentation for RocksDB, you basically say, basically the documentation says, oh, we have no idea what is the appropriate configuration, it's complex. To the point where Facebook literally uses machine learning to find the optimal configuration to figure out how things are going. I have issues with that approach because if you need to apply that level of sophistication to your configuration to get appropriate performance, that probably means that you have a really complex system. With RavenDB, we try to really not think about that. You have the ability inside of RavenDB to place resource limits, and there's quite a lot of configuration which is there in case of. For the most part, the idea here is that we always want to do dynamic resource allocations. Given the constraint of the system, RavenDB will use as much memory as it can. It will use as much CPU as it's possible to do so, but it will do so in a very smart way. And we see exactly how it works in a little bit. The automatic index feature of RavenDB is something that I'm particularly proud of. Not because of the actual feature, because this is a very visible example of the philosophy behind RavenDB. You make a query to RavenDB. RavenDB will analyze and create the appropriate index automatically. It will look at the other state that you have, remove all indexes, do everything that it needs to do because it doesn't need you to wipe after itself. You can just let it run and it will figure things out. Now, I want to talk about resiliency. Cloudflare had an outage last month, and they published a postmortem that was quite interesting. Effectively, what they had was this setup. They're using etcd, and basically they had a router that failed and created intermediate connection problems between these two nodes. Now, this and this worked fine. So node 2 was able to talk to node 1 and node 3. Node 3 and node 1 could sometimes talk to one another. And the problem with this approach is that node 3 and node 1 kept saying, oh, I can't talk to the other node, I have to call elections. And the cluster basically kept running elections non-stop. Now, the issue with doing that is that if the cluster is continually running elections, it can't actually do its actual job. So I actually found it quite fascinating because the implementation that they had missed something critical about the consensus implementation. But I actually thought it was interesting for another reason, because when I compare it to the way that RavenDB work, the behavior is very different. For example, the actual outage here was 6 minutes in length. So there was a problem with the router and it fixed itself, which is something that happened all the time. But because the cluster was unavailable, then automatically processes trigger a failover of the primary from one node to the other. The replicas had to rebuild, and the load on the new primary was so high that it kept dropping the queries and connections. In effect, you had to have 3 separate independent operations happen all at once to trigger this. Now, I don't know if Cloudflare intended to do that, but their story is actually really impressive for a different reason. It's really impressive because it means that their networking is flat out amazing. Because if you haven't run into this problem, and they haven't, because otherwise they would enable the flag that fixes that, and which is literally, by the way, a flag. You have to enable pre-voting in the etcd configuration to make sure that this doesn't happen. But it's not enabled by default for some whatever reason, and they didn't hit it for years and years, which is to me just absolutely insane. The way that RavenDB work is that we have the same consensus algorithm as etcd, the RAF protocol, but by default, and there is no flag to disable that, we run pre-votes because we assume the network is hostile and bad for us. It means that RavenDB actually uses two separate protocols to run its distributed machinery. One of them is the consensus protocol, which is meant to control the entire cluster. But we also use the gossip protocol to talk between the nodes directly, which is a hell of a lot more work. Why do we do that? And the answer is to make operations easy. Because with the RavenDB cluster, you can take it down to a single node and it will work. And when you scale back up, when you scale it back again, when the router fixes itself, when the other nodes come back up, then we'll be able to seamlessly join into them. The whole idea of RavenDB is that you want to be resilient. We will accept you write at all times because we think that, yeah, we send us some data to write. That's probably important. Let's not drop it. And the notion that failures are something that happen all the time. We were very lucky with one of our customers, and they're running a fast food restaurant. And you can imagine that this is roughly what we have to deal with. And this is the operator, a teenager on minimum wage, and their technical facilities are all about, okay, what is the Instagram filter that I can use for this picture? If you ask them, analyze why the server is slow, they're going to look at you very strangely. If you have any teenagers, you know the look. So that's a problem. RavenDB had to be able to survive in that kind of environment. It had to be smart, it had to be self-sufficient. And we actually built a lot of features around that, which end up being really useful in a lot of other scenarios. So let's talk about it. The first thing that happens when you run RavenDB is that you have the cluster observer. And the cluster observer continuously monitors the system. Here we have a RavenDB database. And right now, this is actually running only on a single node. This is still a cluster. It's a single node cluster, but this is still a cluster. Now, the interesting about this is that in here, you can see that I have quite a lot of information. This is the cluster observer log and the set of operations, set of operations that is related to that. For example, you can see that library database was unreachable. Therefore, it was moved to rehab. And at some point, it was reachable, and then it was promoted. And now we're okay. Here is the cluster deciding that a particular index is stale. So it should be moved to rehab, to idle mode, to take less resources from the system. The idea is that at any given time, we have someone who is watching the system. Now, why is it the cluster leader? This is the cluster leader because those are the kind of decisions that require consensus. I don't want to make unilateral decisions by some agent that may not have the full view. So all of those decisions has to be voted by the nodes and agreed on by a majority of them. Now, the cluster observer actually does quite a lot. It detects when node is down. It detects, there is capacities. You saw that with, this index hasn't been used. We can move it to idle. It does a whole bunch of things. In particular, it also allows us to effectively pretend that it is an administrator that operates at all times. So for example, if I'm looking here and I'm seeing, okay, I have a down node, I can go and add that database to another node and start replicating. If a node is down, I can reassign the backup task to another node, so I have backup running. If I'm seeing that a node has capacity issues, run out of disk space, something like that, I can change the database topology so a node that is still okay can be the primary node for this database. So effectively, you have someone who is continuously monitoring the cluster and can take action as soon as possible in order to handle that. Now, one of the things that we have to deal with this environment is the fact that we may actually need to consider that we are wrong. In this case, I have a database, and this is not a small database. So it's about 1.4 terabyte of disk space. Now, if I decide that I need to move it to a different location because it doesn't have enough replicas, as you can imagine, that might take a while. During that time, the down node may come back up, in which case the cluster observer says that, oh, okay, I don't need that, and I can abort. And a lot of those features are also designed to run in a hostile environment. If I have enough load that I just lost a node, and I'm trying to create a new replica, which would create additional load on the system, that's bad. We have try to make sure that as much as possible, those actions are safe. They are throttle, they are not going to push you over the edge. At the same time, we have to remember that these sort of operations only happen at the cluster level. We can't assume that we have a cluster. Why is that? Why can't we assume that? That seems like something that I would want to assume. Well, what happened if there was an error? So even without the cluster, there are certain things that we need to handle on our own. So the node itself is going to continuously monitor itself. Notice that like we have two levels of the cluster and the cluster with consensus and the gossip between the databases, we have monitoring at the cluster level and the database level. And both of them can act independently from one another. And that means that we can detect, oh, I'm using too much memory. Okay, what am I supposed to do now? Let's adjust ourselves. Let's clear the buffer. Let's use smaller batch sizes to process things. Let's try to reduce as much as possible work that doesn't need to happen. In the cloud, it's very common for you to run on burstable instances. And one of the really annoying things about burstable instances is that if you run out of CPU credits, then the cloud will effectively pull the plug on your machine. There is no code that is running. There is no lock that you're holding. The virtual machine doesn't schedule the hypervisor doesn't schedule your virtual machine. This has the effect of, oh, my machine is frozen. I can't SSH to that. I have no input. From the point of view of the machine itself, time just jumps ahead. That's really annoying to debug. RavenDB has the ability to monitor that, to say, oh, I know when I'm going too low. I can alert on that. I can take action. So I like to think about this as AAA. And here is a good example. So the CPU credits are exhausted. So we'll start throttling our internal processes. We will stop indexing because we need to have sufficient CPU credits. We're always monitoring the writes to the disk because this is one of the most common issues with database performance, that you don't have enough disk space. So you don't have enough IOPS, you have a slow disk, something like that. So that's a problem. But we deal with that by monitoring and alerting on that. And now you know, okay, at this particular point in time, and at this particular path, we had a slow I/O. You can go and look at the storage metrics to understand why. You can go and talk to the storage team. Maybe get more IOPS from the cloud. Maybe get better quality of service settings from the storage team, those sort of things. But the key here is that you don't need to think. And that's really important, because if you have to think, then you're going into, you know, that the saying about debugging. A debugging is a murder mystery where you are the investigator, the victim, and the murderer all at the same time. And it's hard, and it's sometimes you would spend days and weeks trying to figure something out because the system will tell you. So I don't want to have a black box. I want to have something that is efficient as possible. Here's a good example of, okay, I'm actually running on low memory node. This is actually running RavenDB on a 16 megabyte container. And I was quite surprised that it worked. But okay, RavenDB will detect that this is a problem. It will adjust its own behavior. So you don't have to think about it. You don't have to consider this. This is the list of alerts that, this is a partial list of all of the things that RavenDB will monitor and alert you on. And I talked about CPU exhaustions, CPU credit exhaustions, or slow I/O, but something as trivial as, hey, this is about to run out. You need to extend that. You need to clear some space. Oh, you have misconfiguration. You're running RavenDB with low swap. So if we are using too much memory, then we might trigger the out of memory killer. There is a whole bunch of errors that are not about the server at all. It's about the way that you use RavenDB. For example, if you're using and this is a somewhat common mistake, if you're creating a document store per request, then you're losing out on a lot of features inside of RavenDB. What do you mean by that? I mean that you're missing the HTTP cache, you're missing a connection pooling, a whole bunch of things that are important. So RavenDB will actually monitor and tell you, hey, you're probably doing something wrong. Here is the problem. So you don't need, oh, why is my system slow? Every individual query seems fast. And then you realize that, oh, I'm creating UTCP connection each time. I'm not using any caching, all of those sort of things. By the way, all of those sort of things are things that happen for you by default. You don't need to configure connection pooling. There is not something like PG Bouncer for RavenDB. Things just work, and they work to do the right thing. With RavenDB, if you have a query that is too slow, we'll give you an alert. Hey, this might be a problem. This is actually something that we do intentionally, because if there is a slow query, I want you to know about that. And what will probably happen is that you will call me about this. Then it says, yes, this is slow. Let's fix that. Because slow is usually a bug. If you have a RavenDB supports document up to 2 GB or so. But if you have a document that is in the multi-megabyte range, that's just awkward. So we alert you on, hey, this might be a problem. We alert you, hey, you try to do a query that just got 50,000 items. We're doing a whole bunch of things proactively, explicitly, in order to make sure that you don't need to think about that. Now, I mentioned already that RavenDB will analyze queries and create appropriate indexes. This is a unique feature in the database land. There are very, very few other databases that does that, and they tend to be on the traumatic end of things if you need to trigger that. With RavenDB, this is just something that happens effectively constantly. The interesting thing about this is that RavenDB needs to do a whole bunch of work behind the scenes. And just to give you some idea, in this database, and again, not a trivial database, I have some annotations. So what I'm going to do right now, I'm going to issue a full text search query on this, just to see how this works on, and this is text. Now this is going to run. And you can see that it starts indexing. Notice this. RavenDB actually uses not a lot of indexing, not a lot of memory right now, even though we're indexing 15,000 a second. By the way, not that at this rate it's going to take us a few hours to do that. But the system is up and running. We get some result almost immediately. Here we go. Now, try to imagine doing something like that on a terabyte database in production. The reason I mentioned that, notice that, okay, we're using slightly more memory. We're indexing the data, but we're doing that very, very carefully. Introducing a new index isn't going to kill the system. Is it going to cause us to do too much? But I noticed that the actual memory usage is almost to the top of what this machine is capable. But what RavenDB actually does is a lot less than that. All of that is mostly the page cache, basically. Another thing that is important that happens here is that when we are running queries, RavenDB is going to analyze them and look at the indexes that they use. And then it's going to give more resources to those indexes. So over time, not only are you going to see better indexes because you give RavenDB more information, you're also going to see that RavenDB is actually able to handle that, to understand, okay, this is a popular index, this is not popular index, let's give this one more resources, without really the admin having to think about that. Now, let's talk about something else that is important. And again, you get this. RavenDB will actually give it to you directly. If we're about to run out of this space, it will tell us. But if I'm looking at this is 1.41 terabyte database. And it has 1.35 million, so 1.35 billion items. Why is it so big? I have no idea, but I can find out because RavenDB will explicitly tell me. Okay, so the actual database is just 1 terabyte in size. We have a few other indexes, and this looks like this is a big index. And digging deeper, I can start seeing, okay, what's going on here? Why is the system this big? And after I'm seeing what's happened, if I have, for example, if I deleted some data or if I did something, I can hit compact. Not on this particular database, it's actually too big for us right now, but you can see how that works. And apparently there is quite a lot of data that we have to go through now, so it takes longer than usual. But again, the idea here, we run, we do things, we don't need to really consider or think about that. Okay, now here's another common pain point, certificate handling. In this case, let's see here, RavenDB uses X59 client certificate to authenticate. And we use the server certificate for mutual authentication. We use the server certificate to encrypt the data over the wire. And that's awesome. That's viable on almost any regulatory approach that you want. If you need to match ISO 2701, if you need to PCI, HIPAA, those sort of things, it works. There is one problem with that. Certificates expire. And it is an absolute guarantee that the certificate will expire and you will be hit by that. I literally just went and searched certificate expiration outage, and I got this one. And just sort by date, and you'll find a lot of those. So that is the operation overhead of certificates. So with RavenDB, we did a whole bunch of things around that. To start with, by default, if you just use the setup wizard, RavenDB can just run and use the Let's Encrypt API to generate automatic certificate renewal. All of that, it's on RavenDB. Most cases you don't never really have to think about that. If you are running in other environments, for example, we have a user who is running on Kubernetes and he wants to use the certificate generated by the Kubernetes system. Well, you can do that using this option. Okay, now we can, that's interesting. So it took a while, but actual data is this. We pre-reserve some disk space, it looks like. And we can dig deeper, and there are quite a, so just the names of all of the documents is almost 200 gigabytes. And this is mostly because we have names like this. And if you're looking at the tables itself, almost 500 is for this. We can also tell from here, you can see that there are no there is one compression dictionary, but no, sorry, there are no compression dictionaries. So it doesn't use compression. That's interesting. That's probably something that we might want to consider. So we can also go here to the indexes and dig deep and see, oh, here are your files. And here you can see some interesting files and sizes. Now, the whole idea behind this is not so much that this is actionable to you, but the information is available. It's not hidden or hard to understand. Now, docs. I want to enable to look at this. So server configuration. We also work quite hard on making sure that we have the appropriate documentation for all of those sorts of things. And here's the idea. You can run a command, which is some script that would fetch the value to you. For example, ping the certificate manager in Kubernetes. Oh, you want us to renew? No problem, we will run it and manage everything for you. So the whole idea is that in many cases, we prefer the automated approach. Now, let's talk about something that is trivial and fun at the same time. We are running a RavenDB cluster that obviously uses certificate for authentication and want to integrate that with another RavenDB cluster. If we're using Let's Encrypt for both of them, then we have a problem. How do I authenticate those two clusters? Well, they have to use the certificates. But the server certificates in this environment is changed about every 2 months. So it's not a good idea. But because in 2 months, I would have to go and re-register the certificate. And this is what happens when you do things like that. Instead, RavenDB uses public key pinning, similar to APKP. And as long as you have the same public key and signer, we will renew your authentication on the certificate, which means that this is an environment where certificate change. As long as you keep the same signer and private key, you can move forward, and keeping the same signer and private key is the default. And that's important. That's important because now we are talking about a major operational overhead that will just remove from your life. Now, there is a problem. However much we try, eventually things will fail. There is this really great article, How Complex Systems Fail, and this is not a big one. There we go. So it talks about this. I would very strongly recommend that you would read that. I'm actually going to put that in the chat. And the whole idea is that complex systems is almost always running in some partial failure mode. There's almost always, in order to have actual failure, or you have to have multiple concurrent issues that happen at the same time. You're driving on a wet road and you didn't do oil change and. There is almost multiple failures in the system that is meant to prevent the problem that actually that had to fail all at the same time. With RavenDB, we know that this happens, so we need to think about how do we deal with that, and we have to deal with this because the first thing that an operator is going to do is just restart things, because in 95% of the cases, this is how things get resolved. In 95% of the cases, it gets you back on your feet, but it hides what the problem was. It doesn't tell you what happened. So, and this is, by the way, the priority that we have. First, get the system running, then figure out what was going on. In order to handle that, RavenDB has the notion of debug package. There is a problem. I'm going here, I'm hitting this. This should take about 5 to 15 seconds to run. And the output of that is a zip file. And we're going to see this zip file contain quite a lot of information about my system. It contains enough information in most cases to diagnose what the problem is and to operate on top of that. And immediately after I hit this and got the relevant zip file, I'm able to restart the system, but I haven't lost my state. By the way, this is actually taking longer than expected. I'm not sure why, so I'm going to do something else. I'm going to go here and see. No high CPU activity, nothing that, oh, here we go. Oh, so that's the problem. Let's see. Notice the, oh, come on. 1 second. For some reason, I keep getting this error and I need to fix that. But in almost all cases, it's easier to just do, no, not this one. There we go. Use 7-zip, that works with no issues. So now we can see that we have something here that is very big. This guy. And this gives us almost excruciating details about what happens inside the database. So that's probably why, because the database is in the terabyte range, that's why we got the time to generate this. Now, let's go here and ask, okay, what's my CPU? Here's my CPU utilization, stuff like that. I can go and say, hey, what's taking my CPU? No, I can see that. Literally, all of the information that I need is right here. The list is sorted by how busy the CPU is. But you can also see it here. So the whole idea is that as much as possible, we want to remove guessing and thinking, and I know what's going on. Here we go. Here is the amount of memory, how much is available, all of those sorts of things. In particular, I can also look at the memstat, which is TCP, active connections. There's a whole bunch of things, but here is the thing that I care most about. Okay, now we can start seeing, okay, how many allocations do I have? Which one is responsible for them? A whole bunch of other stuff like that that can be incredibly useful in trying to understand what and who and why. Another really important thing, the reason you get a zip file is that if there is an issue, you can also send it to support. You don't have to try to understand everything yourself. Oh, you hit it, you create a debug package, send it to support, we will look into that. That's one of the reasons that we have a support system in the first place, and why we are trying very hard to make sure that you would never need to use that. So there are a lot of other inspection points. Now you can go to the debug routes endpoint. Just to give you some idea, I like to, this is the public endpoint, but there are literally, let's see. So there are 49 different endpoints that you can use to inspect the state of RavenDB. And just to give you some idea, I can use this. Say, hey, give me the ping time between your servers, which is very useful if you want to analyze issues such as connectivity. There is also this thing. Let's run it against this. This is going to think, notice that we're running the system on this, on an actively processing system. This is going to think about a while. And then we are going to get a file. In particular, we're going to get this file. And we're going to be able to run this command. This is dump report. Which means, and let me just, but okay. In that particular endpoint, I can see that we have quite a few of these things. Long arrays, byte arrays. Interesting. Let's, okay. So I will talk about this in a second. I need to run something in order to make this work. But the whole idea is that, okay, this is a live running system, and now you get these sort of things from the system. You can run admin debug allocation. That should work with no issue. Memory / allocations. Now, this is going to monitor ourselves. And now you can see, okay, how many allocation do I have? And what is the size? In many cases, that gives me a lot of information. Now, I dearly hope that you never need to know all of those sort of things, but they are there and they're available. And it can be a lifesaver when you try to inspect what's going on. In the same sense that we expose and externalize a lot of information. You can look at running queries, and let me go and run a query. Here is a query. Takes some time. By the way, the reason it takes some time is that this was made idle, so we unloaded that. But here is the query, and I could see that. But next time that I'm running a query on this, it's supposed to be much faster. Apparently not in this environment, which is actually quite interesting to me, but I will investigate it later. You can see here all of the details and everything. Okay. Now, I already mentioned IOStats earlier, but it might be easier. This is IOStats for the server. Let's go and look at IOStats for that particular system, for that particular database. Now you can see that we have writes here, and I can measure individual writes to the disk. I can go here and look at the queries that are being made. And once this is done running, then we will see it here. There we go. Took quite a while. There's this. So I can literally see what's going on, how the system is behaving, how everything's here. In a few seconds, I'm going to start seeing all of the details from the debug log. So the fact that we externalize all of that information is huge. The fact that you can look, oh, what is the state of my system in here? All of that. We're trying to give you as much information as possible. Now, remember this error that I got earlier? You need to remember to do that. I updated the server and forgot to do this, but run this, and now you have enabled debugging capabilities to do things such as what is my system doing, how is my stack test behave, those sorts of things. Here's another example of the kind of behavior that we want. Oh, you start RavenDB, you didn't set up the appropriate permissions to run, you need to run this. Run this command, we're good. Everything will work. So we spent a lot of time on optimizing the behavior of the system to make it easier for the user to run. If there is an error, then we try to handle it internally. If there is something that we can do, I don't want to try to run this independently, and I shouldn't be able to anyway. But it means that I can do that, and I can just give it to the user. Don't do any work. Don't need to think. Here is what you need to do. Here is an example of another thing that we can do. I can go to running server and hit capture. It gives me the stack traces of exactly what's going on. So I can figure things out. I can understand how those sorts of things are working. That's what I have. Now is the time for questions. While I'm waiting for questions, I would like to remind you that we're offering live demos. If you have a scenario or something like that, go to this URL, give us your contact, give some details. We would love to talk to you about your details and scenario. Okay, so Lars is asking how much of this can be used on cloud hosting? All of this. I haven't shown you a single thing that you cannot do on the cloud. That's important. In many cases, if you run on the cloud, you are shut down from all of the interesting things that the system has. I know of people who are running Elastic instances on Azure, and they're very frustrated because they don't have access to the logs. So if there is an error, open a support call. We'll get back to you in 24 hours, something like that. Everything I've shown you is available to operator, which is the level that you have in the cloud. And now there are other things that you cannot do in the cloud, and this is one of them. So this is something that I would rather that you would not do, but you can do things like this. And okay, let's inspect the live configuration of the system. That's interesting. You can also actually modify the running configuration of the system, which is why you should never do that, and this is not available on the cloud. But aside from that, the whole thing is yours. Walter is asking, can indexes be automatically repaired after an unexpected node shutdown? No, and you don't need to. I'm going to assume that the issue that you're talking about is related to a 3.5, where this is an issue. If you do a hard restart or something like that in 3.5, you may corrupt your indexes. One of the things that we did in 4.0 was to change the equation entirely, so you no longer have to do that because indexes are now transactional. That means that the indexes that you use are, if there is an unexpected shutdown, you may lose a batch, but you just have to redo that on restart. No harm, no foul. Other things that are interesting is what happens when you run out of disk space. If you look here, this index is running quite heavily. And here we go. So it's already taking 10 gigabytes. It's going to take more over time. Notice, by the way, that a lot of that is temporary files that would be cleared out later on. We can also look here and see that here are some of the journals that we have, the segments that we have. Now, why does it matter? It matters because you may end up with an error if you run out of disk space while the index is built, in which case we'll give you an error and recover. And why do I have Java updates? No idea. Anyway, the short answer is that indexes don't need to be automatically repaired because an unexpected node shutdown will not cause you any issues. Other things that are interesting, you can see here that there is quite a lot of details around here. For example, this was a problem, it rebuilt and moved on. Here is the swap size error that I mentioned. I created a certificate for Pavel, a bunch of other stuff like that. So you have a history of operations at your feet, which you can utilize. You can understand what's going on. There are other things that might be important. If I'm looking at this, then you can see that I have this index. We actually don't expose that in the UI right now. This is an upcoming feature, but you can look at this. Okay, what's the history of this thing? So you can go to the database record and look at index history. And now you can see this and this. And eventually what we have here. So you can see the history of changes, how they happen, who made them. We used to have an issue where a user would say, oh, someone is keep resetting the definition of my index. And they were very upset about that because, oh, RavenDB keep resetting my system to the old index. And with this, we're able to say, oh, you know what? you're absolutely right. There is this team which is running so and so, and that's the team that keeps resetting the index. And we're able to say, oh yeah, that's the old system that is still running. We forgot to disable the indexes from there. For that matter, you can also do, again, with indexes. You can specify, you know what? Where is it? Here you go. I don't allow to change that. Attempts to modify this index would fail. So I can discover and work on that. You can see things like this. I'm giving you live information about what's going on, how things are working, how to expect, all in the attempt to give you as much information as possible. You don't have to think, because I want you to think about the business scenario, not what did I do to make RavenDB run or not. This is it, everyone. I don't think we have any further questions. Thank you so much for showing up for this webinar. I will remind you again, you can request a live demo. If you're using RavenDB already, and I saw from the poll that quite a lot of you are, I would love to hear from you. What are you doing with RavenDB? How does it help you? What are the things that are good? What are the things that you find challenging? If you have issues with operations of RavenDB, let us know. I consider operations to be a paramount important. And this is interesting because this is not something that you typically see. All of those features that I talk about they take a lot of time and effort to build. And the whole idea is that you never really have to think about them. That you won't notice that there isn't so much friction in your life because RavenDB already took care of that. And I think this is it. You can also ping me on LinkedIn, connect with me, tell me your story. I would love to hear from you. And that's it. Thank you very much.